I mean, it was serious unto death. A person can go into a coma with that, and they've got to be intubated. They've got to flush the system with oxygen. All right, now this and right here, I just simply say right here, lungs. The process is reversed. HCO3 minus re-enters the red blood cell. Chloride ion moves back to the plasma. Carbonic acid is reformed in the presence of Ca at the lung level. It becomes water and carbon dioxide. You're not going to have to write all that. Just know at the lung level, when we exhale, we're exhaling carbon dioxide, and also the breath is more. That's water vapor. Water, so that it reverses. The carbonic acid, pardon me, the carbonic anhydrase also at the lung level reverses. In other words, the carbonic acid is reformed in the presence of carbonic anhydrase. At the lung level, it becomes carbon dioxide and water. And this is exhaled. CO2 attached to hemoglobin, and that in plasma is also exhaled. So this is the way carbon dioxide is transported. So let me go back over that now. And here's what you need to get out of it. Basically, you're not going to have to write all this stuff. So don't worry about that. All right, first of all, where does CO2 and H2O come from in the body? From the electron transport, the Krebs cycle, and all that business. That's CO2 and H2O. CO2 and H2O diffuses out of cells through the plasma to the red blood cell. Now, at the red blood cell, in the presence of who? This will be on your test. In the presence of who or what causes CO2 to combine with H2O? Carbonic and good, you said it. Carbonic anhydrase. Carbonic anhydrase causes CO2 plus H2O in the blood cell to form carbonic acid. Now, is that a stable acid? No. That's a weak acid. It's unstable. What does it do? It ionizes into hydrogen plus HCO3. Who takes care of the hydrogen? Hemoglobin. What happens to the HCO3? It moves out of the cell as who comes in? Oh, good job. All right, I think y'all kind of got it. Just look over it, just read over it, read that, and look at the diagram. This is on the, in other words, I think I've got this same thing right here. I think I may have added a little bit to this. I just say lungs. I think I added to this right down at the bottom, didn't I? Didn't I add this right at the very bottom? I think I added this, maybe did I expand on this just a little bit on here, expanded? In other words, lungs, process reversed, HCO3 minus re-enters the red blood cell at the lung level, and that's in the capillaries of the alveoli. Chlorine moves back to the plasma. Carbonic acid is reformed in the presence of that. Ca, I always remember that. There was no cowboy type guy when I was growing up. He was he lived in a little town close by. He always had boots on and rode bareback, horses and all that kind of stuff. His name was C.A. Bettinger. For some reason, when I see C.A., I never wasn't a close acquaintance of that guy. I knew who he was. But Ca stands for carbonic anhydrase, and it is an enzyme. Carbonic anhydrase is an enzyme which at the tissue level facilitates the combining of H2O and CO2, and at the lung level, it causes carbonic acid to split into CO2 and H2O, and we exhale. Boy, I cannot tell you the importance of avoiding chronic obstructive pulmonary disease. I cannot emphasize to you enough that of doing everything you can to avoid. I mean, you might not think anything about it now, but if you get older and if you get afflicted or get strapped with chronic obstructive pulmonary disease, you are in a bad way. Trust me, it's a bad deal. It is a bad deal. Because, like I was telling you, high blood pressure, hypertension, and all that kind of stuff is the silent disease. But if you can't breathe, if you're struggling to breathe, you know it. I mean, you'll know it. And it's horrible. And you can't really, it doesn't heal itself. It can ease up a little bit by doing some things right, but it stays a bad situation. Like, how many of you have known someone, other than me, of course, have known someone with chronic obstructive pulmonary disease. Yeah, is it a fun thing to see? Or is it a fun thing for those people? Hell no. It's not at all. You know, it's not. It's really a rugged thing. Alright, so, but anyway, everybody, there it is. And lungs, you know, that's very important. And I didn't show it on the projector. I don't have it on the projector. I showed it. I gave you a handout sheet of it. It's what I did, not on the projector. Alright, now everybody right here, and that just tells you right there, it's a bicarbonate combined with sodium. That's talking about the chloride shift. That's just telling what we've already talked about. Chloride combined, we've already talked about that. That's the thing right there, and that is it. This is known as the chloride shift, and that the main thing you need to know is what is the chloride shift. And I'll try to trick you on the test now. The chloride shift is where chlorine, I'll just say chlorine, it's chloride ion, where chlorine moves into the who. The RBC as who moves out, as bicarbonate moves out. That's called the chloride shift. And the purpose of that is to maintain electrical stability in the cell situation. So that is it. Does anybody have a question? You kind of understand this or think you might once you read over it? You kind of, once you go over it a little bit, if anybody has a question, be sure and ask
This is the chloride shift?
Yes, sir. That is the chloride shift showing chlorine, the chloride moving in, and the bicarbonate moving out. So you have normally primary extracellular substance is sodium chloride. Potassium is a cation inside the cell. Potassium, this is part of the makeup. And so the chloride shift is where the chloride, of course this is an ionic molecule, where chlorine moves in as as bicarbonate moves out. The chloride moves in, combines to the potassium as bicarbonate moves out. That's the chloride shift. Just remember now, because I'll try to trick you. I say the chloride shift, that is where I'll say something like this. That is where, I might say, that is where potassium moves into the cell as chlorine moves out. Well, that's wrong. Chlorine moves in as bicarbonate moves out. So I might have something along those lines. As long as you know what it is. Know that chlorine moves in, bicarbonate moves out. Who does the bicarbonate? And what is the specific way that most of the carbon dioxide is carried in the blood? It's carried as sodium bicarbonate, specifically. Now, generally, the test question I had on that test, as a bicarbonate, and that's true. The majority. If you get real specific with it, it's sodium bicarbonate. This is the way most of it's carried, as NaHCO3, sodium bicarbonate. And we got to be able to take care of the carbon dioxide. We have to be able to do that. I mean, there's no ifs, ands, and buts about that. We have to be able to do it. All right, but anyway, that's the chloride shift, and you'll come across that one. The net effect of all these reactions is that CO2 is carried from the tissues as bicarbonate ions in the plasma. CO2, the net effect of all this stuff we've been talking about is that carbon dioxide is carried from tissue cells as bicarbonate, that is the majority of it, as a bicarbonate ions in the plasma. And so that's just the deal on carbon dioxide. I do want to make you aware of this, and this means a whole lot. In fact, I was talking to that woman in my class, in my 2401, that woman, what I said her name was.